Hey everybody, so this video is going to be on absolute and comparative advantage, and we're going to sprinkle in some terms of trade in there as well. So the first thing we're going to notice is I have a PPC already drawn up and ready to go. So what we're going to do is we're going to take the information from the PPC here and we're going to plug it into this particular matrix right now, right? I already plugged it in. So we can see that the United States can produce 100, I'm sorry, I'm using the wrong setting there, 100 berries or 50 bananas, so I already plugged those numbers in. And El Salvador can produce 50 berries or 150 bananas, and I already plugged those numbers in, and we're going to get to work on this as soon as I go over the formula with you guys, because there is a math formula here. Math is involved. So the formula we need to learn for this particular lesson is other goes over, because it is an input problem, right? If it's an input problem, this is the formula that we need to use. So what do you mean by other goes over? I'm glad you guys ask. You always ask such good questions, right? So in this case, right, I'm trying to find out if the United States is going to take their time to produce one berry, how many bananas do they have to give up, right? So in this, we have to remember, right, in this particular scenario, you have to pretend that when we're doing this, they're going to produce nothing but that particular item. So if we're producing nothing but berries, we can produce 100 of them. That's why I wrote 100 there. So when they choose to produce one berry, how many bananas do they give up? Well, we have to bring this number right here over here. So it's going to be 50 over 100, and I know that equals 1/2 a banana. All right, so if we do the same thing right now with bananas, this time we're going to bring the 100 over here, put it over the 50, and anytime the United States wants to produce a banana, it's going to cost them 2 berries. That is what I mean by other goes over. We take the number that is in the other square and we put it over the number in the square we're working with, and that will give us our ratio, the ratio we're looking for, right? So if we look at El Salvador, when they want to produce a berry, what do they give up? Well, here it's going to be 150 over 50, and that's going to be three bananas that they give up because they chose to produce berries at the time instead of bananas. So if they choose to produce bananas, all bananas, every time they produce one banana, one unit of bananas, one bunch of bananas, however you guys want to think about it, how many berries are they going to give up? Well, we're going to put the 50 over 150, and that's going to be 1/3 of a berry. So now what we have to ask ourselves, once we have our little numbers up, and we know what the answer is, we need to figure out who has the comparative advantage in the production of berries and bananas. Now here, guys, what we want to remember is that we want to pay the cheapest amount possible at all times. So what does this mean? This means that I'd rather pay half a banana than 3 bananas. So the United States has the comparative advantage in berries. What about bananas? Well, in this particular case, it so happens to be that El Salvador has the comparative advantage. Why? Because they only give up 1/3 of a berry when they produce one banana, while the United States loses 2 berries for every banana that we produce. We want to pay 33 cents instead of $2. So, of course, that means El Salvador will have the comparative advantage in bananas. So let's talk input problems, right? Because this is an output comparative advantage problem, so we need to look at the input problems now. Okay, so right now we are looking at what looks to be something just like we were working on, but there's one little difference. You see that little 1 right there? That changes everything. This question is asking us how many minutes it takes for Debbie or Bobby to clean one room or to mow one lawn. So we're talking about time. Time is not going to be an output. This is going to be an input. It is a resource for us, right? We don't want to waste our time every single day of our life. That would make everything pretty meaningless, right? So we want to be as efficient as possible while we're either cleaning the room or mowing the lawn. And we want to find out who can clean the room more efficiently and who can mow the lawn more efficiently. There is a change in the formula since this is an input problem, right? The formula here would be other goes under. Other goes under, right? So we're going to take the 30 and we're going to put it under the 150, and the 150 will go under the 90. I'm sorry, in the 30 in this particular case. All right, so once we do that, right, in the time it took Debbie to clean one room, so it's going to be 30 over 150. She could have done 1/5 of the lawn. And the time it took for her to do one lawn, it's going to be 150 over 30. She could have cleaned 5 rooms. Bobby, in the time it takes for him to clean one room, he could have done 3 lawns. And in the time it took for him to do one lawn, it's going to cost him 1/3 of a room. So here we can see that Debbie has the comparative advantage when it comes to input, right? Her effort, her time when they clean rooms. She can clean one room in 30 minutes, while Bobby can clean it in 90. She has the absolute advantage because she uses less resources, less time, but she also has a comparative advantage because she loses out on less. Bobby loses the opportunity to mow 3 lawns, while she only loses the opportunity to mow 1/5 of a lawn. So Debbie should be cleaning rooms, and Bobby should be mowing the lawn. Why? Because in the time it takes Debbie to to mow one lawn, she could have cleaned 5 rooms. And when Bobby chooses to mow a lawn, it only takes him the same time as it would have to do 1/3 of a room. All right? So please remember the difference between input and output, and how we figure out who has the comparative advantage and why on a particular thing. All right, so here we have another comparative advantage problem. This is going to be an output problem because we cannot trade time with each other. So we're going to be trading resources with each other, right? In this case, we're talking about fish or shrimp, right? Japan can produce 100 fish or 25 shrimp, while Malaysia can produce 50 fish or 200 shrimp. Now, we want to know who has a comparative advantage in fish and shrimp. So one country can concentrate and catch nothing but fish, while the other concentrate on catching nothing but shrimp. And this way they can help each other in trade and get more of the other particular good or service that they could on their own. So when Japan chooses to produce nothing but fish, it loses out on 1/4 of shrimp. And when they want to catch shrimp instead, they give up on 4 fish. While Malaysia, when they want to go catch a fish, it's going to cost them 4 shrimp. And when they want to go catch shrimp, it's going to cost them 1/4 of a fish. What does this mean? This means that Japan should concentrate on catching nothing but fish, while Malaysia should concentrate on catching nothing but shrimp. All right, so now what we have to do, we found the comparative advantage. We have to find terms of trade that will be acceptable for both countries. All right, so Japan is going to be catching fish, while Malaysia is going to be catching shrimp. So how do we determine what is an acceptable term of trade for both countries, guys? Well, this is what we need to pay attention to. This particular number and not the ones that are circled, right? Because we want to find out what's going to be an acceptable terms of trade, right? So we need to look at this number in particular, and anything less than 4 will work. So let's see if this indeed does work. Any number less than 4, let's try 1 fish for 2 shrimp. Is this going to be acceptable, right? So currently, when Japan wants to catch shrimp, because remember, they're going to be trading for shrimp, they're going to be trading their fish for shrimp, right? So when they wanted to take their own time to catch that shrimp, it cost them 4 fish. Now they're only going to be paying 1 fish. That's going to be acceptable for Japan. And in return, they're going to be getting back 2 shrimp instead of just 1. So that works for Japan. Is this going to work for Malaysia, though? Well, currently Malaysia is paying 4 shrimp for 1 fish. Now they're only going to be paying 2. This is going to be a better deal for Malaysia, so that's going to work. They could do 1 for 3, and that would work. Actually, you could do 2 for 1, and this would work too, because that would still cost Japan less fish than on their own, right? They could do 3 for 1 or 1 for 1. All of these numbers work. So remember, when we're looking for an acceptable term of trade, there's not going to be one right answer. There is going to be a range of correct answers. If you guys have any questions, please drop a comment below or just send me a message on Remind.